Kia ora Year 12, this is a video going over the two starter questions from today. So both of these use compound angle formulae. The first one uses sine of a plus b, which is equal to sine a cos b plus cos a sine b. And the second one is going to use cosine of a plus b, which is cos a cos b minus sine a sine b. So the idea here is that we're not going to use a calculator. We're going to use the compound angles to figure out that we can get these exact values for sine of 75 degrees and then sec of 7 pi on 12. So the first one is a tiny bit easier than the second. I want you to pause the video and then use that hint to split things up and do some calculations. Okay, so sine of 75 degrees we can write as sine of 30 degrees plus 45 degrees. So that's sine 30 degrees, cosine of 45 degrees, plus cosine of 30 degrees, sine of 45 degrees. Now, lots of you probably know those values already now, but it's always, if you don't know them inside out, draw the triangles. Sine of 30 degrees is going to be 1/2. Cos of 45 degrees is 1 over root 2 from my other little triangle. And then I've got cos of 30, which is root 3 on 2, and sine of 45, which is 1 on root 2. So that gives me straight away what we need, so 1 plus root 3. Now, if we wanted to rationalize that, if we'd been asked to show something else, we could multiply both fraction lines. Sorry, words are failing my brain. We could multiply the numerator and the denominator by root 2. So we'd do this. So this is rationalizing the denominator from last year. We get root 2 plus root 6 over 4. So that would also be a tick. But in this case, we've been asked to show that. So we can stop right there. Right, the next one, sec of 7 pi on 12. We're going to use the reciprocal relationship there. So sec of 7 pi on 12 is equal to 1 over cosine of 7 pi on 12. Let's figure out what that is first. So cosine of 7 pi on 12 is equal to cosine of 4 pi on 12 plus 3 pi on 12, which is equal to pi on 3 plus pi on 4. Let's just get rid of some of this, although it's going to be all the same numbers again. Right, that gives me what? Well, cosine of pi on 3, cosine of pi on 4, minus sine of pi on 3, sine of pi on 4. And remember, this is not my final answer because this is cosine, not sec. Okay, I bet everyone's hung up the phone now and stopped watching, or hung up the video, whatever you call it. Right, but for those of you who are still there, let's get on with it. So cosine of pi on 3, 1/2 times 1 on root 2 minus 1 on root, let's see, sine of pi on 3 is root 3 on 2. It'll be proper and go in the same order, times 1 on root 2. So that gives me 2 root 2 in the denominator and 1 minus root 3 up here. And sec is just the reciprocal of that. That's why they're called the reciprocal trig functions. So sec of 7 pi on 12 will equal 2 root 2 over 1 minus root 3. And now we're going to rationalize the denominator by multiplying by the conjugate surd, which is something that you learnt last year, but you might have forgotten. Now, when we multiply this out, we get 1. This and this disappear. So 1 minus 3, and expanding my brackets, I get 2 root 2 plus 2 root 6, which is 2 root 2 over negative 2 plus 2 root 6 over negative 2, which is simply negative root 2 minus root 6 as required. So there you go. Thanks for watching. Most of the lesson was spent on independent work today, and just make sure that you are filling in the tracker sheet and keeping up. Tomorrow's lesson is one where I'm going to teach sums and products at the board, so you might want to go into the Google Doc and have a look at those notes ahead of time. There's a linked Google Doc file with some handwritten notes from me on how to do them.